Welcome all. In the previous class, we have discussed about the classification of corrosion. That is, corrosion is mainly classified into two. The first one is dry corrosion or chemical corrosion, and second one is wet corrosion or electrochemical corrosion. In continuation of this, in this session, we will discuss in detail about dry corrosion or chemical corrosion. Let us start our class with this chemical or dry corrosion. It is actually the simplest case of corrosion, and it occurs when the metal is in direct contact with atmospheric gases such as carbon dioxide, hydrogen sulfide, halogen, oxygen, etc., or in direct contact with anhydrous inorganic liquid. Due to corrosion, a corrosion product will be formed. That is sure. And in this case, the corrosion product may be insoluble, soluble, or maybe liquid in nature. Insoluble corrosion product means a solid film is formed on the surface of the metal, and the thickness of the solid film goes on increasing as the corrosion proceeds. After some time, this film prevent the rate of corrosion or decrease the rate of corrosion or prevent the corrosion, because it will prevent the penetration of oxygen or corroding environment into the surface of the metal, and the fresh metal is not exposed to corroding environment. Whereas in the case of if the corrosion product is soluble or liquid, means that as soon as the corrosion product is formed, it is replaced from the surface of the metal. As a result, always a fresh metal surface is exposed to the corroding environment. This leads to excessive corrosion. Now let us see what are the main classification of this dry corrosion or chemical corrosion. It is mainly classified into three. The first one is oxidation corrosion, second one is corrosion by other gases, and third one is liquid metal corrosion. Let us first discuss the oxidation corrosion. This oxidation corrosion takes place by the direct action of oxygen on the surface of the metal at high or low temperature and forms their corresponding metal oxides. This corrosion takes place in the absence of moisture. In the case of alkali and alkaline earth metals, even the reaction of oxygen takes place at ordinary temperature also. But most of other metals except silver, gold and platinum, oxygen react with these metals at higher temperature and forms their corresponding oxides. Now let us see what is the mechanism behind this oxidation corrosion. The first step is the oxygen is adsorbed on the surface of the metal through physisorption. As the temperature is increased, this physisorption is converted into chemisorption. At the same time, metal loses its electrons to the surrounding and it forms a metal ions. And these electrons are taken, that is electrons formed as a result of oxidation of metals, are taken up by oxygen and form the oxide ions. The final step is this oxide ion and metal ions combine to form corresponding metal oxide ion. If the thickness metal oxide layers, if the thickness of this metal oxide layer is greater than 300 angstrom, then this layer is called a scale. If it is less than 300 angstrom, then it is called as a film. Okay, this metal oxide scale or film formed act as a barrier between the metal and the corroding environment, thereby either decrease the rate of corrosion or prevent the corrosion. Or otherwise, in order to occur the oxidation or corrosion further, either the metal ion should diffuse outwards through the scale to the corroding environment, or the oxygen itself diffuse inwards to the underlying metal surface. Since the size of metal ions are very small, they will rapidly diffuse outwards through this metal oxide film to the corroding environment, and this result in excessive corrosion. And the nature of the film decides the continuation of corrosion process, which means that if a metal forms stable film, it will, as I said earlier, it will act as a barrier between the metal and the corroding environment, thereby either decrease the rate of corrosion or prevent the corrosion. For example, metals such as Aluminium, copper, chromium, etc. form such type of stable oxide film on their surface as a result of corrosion. Another case is that if the metal form an unstable film, which means that as soon as the metal oxide film is formed on the surface of the metal as a result of corrosion, it decomposes back to metal and oxygen. In this case also, corrosion should not happen. For example, for metals which forms unstable metal oxide film is copper, silver, gold, and not copper, silver, gold, and platinum. Whereas if a metal forms volatile film, which means that the metal oxide film formed will evaporate as soon as it is formed, and a fresh metal is always exposed to corroding environment, and it will result in a rapid and continuous corrosion. For example, molybdenum forms such type of molybdenum oxide film. It is actually volatile in nature and it evaporates as soon as it is formed. Another case of different nature of this metal oxide film is if the metal forms a porous film. In that case, the oxygen can penetrate to the metal surface through these pores. As a result, metal is exposed to corroding environment and it results in rapid and continuous corrosion. Now let us see second classification of corrosion, that is corrosion by other gases. We have already seen corrosion by oxygen, that is oxidation corrosion. In addition to oxygen, other gases also have corrosive effect on metals. For example, carbon dioxide, sulfur dioxide, chlorine, etc. also have corrosive effect on metals. But the impact of or the extent of corrosion depends on the affinity of this corroding environment with the metal. In this case also, the nature of the formed film will play an important role in the rate of corrosion. Okay. In this case, if the metal forms a protective film, it will decrease the rate of corrosion. For example, chlorine reacts with silver to form a stable protective film which decrease the rate of corrosion of silver further. Whereas, if the metal forms a non-protective film, it increases the rate of corrosion. The example for that is, if a chlorine reacts with tin to form tannic chloride film, which is porous in nature. As a result, the corroding environment can penetrate through the pores and interact with the metallic surface. As a result, the metal will undergo further corrosion. And the final classification of this dry corrosion or chemical corrosion is the liquid metal corrosion. In this reaction, in this corrosion, actually corrosion takes place by the action of liquid metal flowing at high temperature on the surface of solid metal. As a result, either the solid metal dissolved into the liquid metal or the liquid metal that is flowing over the solid metal will penetrate into the solid metal and it will result in the corrosion of solid metal. An example is liquid sodium is used as a heat transfer agent in nuclear reactor and it causes the corrosion of the carrying pipelines. Okay. And today's session, we have seen what is chemical. Let me summarize. In today's session, we have seen what is chemical or dry corrosion, what are the type classification. We have studied that in detail. In the next class, we will study the second classification of corrosion, that is wet corrosion or electrochemical corrosion. Let me conclude. Thank you.